All right, so in this chapter, we're going to be looking at factoring. So this first part here is factoring in multiples of whole numbers. Now, notice what a prime number is. So a prime number is a number which cannot be divided into smaller parts any further. So 2, 3, 5, 11, 13, 17, 19, 23, 29. And those are the first 10 prime numbers. So what we're going to do today in this lesson is we're going to try to break down numbers into their prime factors, okay? Which means the smallest that we can break it down, and a factor is what they multiply, right? So factors of 10, for instance, are 2 and 5. So we multiply 2 and 5 together to make 10. All right. So now if we look at this first question that we have here, so it says write the prime factorization of 2646. So 2,406. So what we're going to do is first just kind of write it down. Some of you do the tree, and that's fine. You can do the tree. I just like writing it out in this method because it just takes less room. So I write down my number, and then I divide it. I know this is a 6, right? So that means it must be divisible by 2. So if I go 2646 divided by 2, what am I left with?
1323.
1323. Okay. Now, this is no longer divisible by 2, is it? No. Is it divisible by 3? Check with the next prime number. So we go, how do we know? Well, 3 and then 4, 5, 6, 7, 8, 9. All the digits add up to a number that's divisible by 3. So it's divisible by 3. So let's divide this by 3. What do we end up with? 441. Okay. And if we don't know that, we just have to do a little scratch work on the side, right? Like this. So 3 divided by 1323, and then go 3 into 13 goes in 4 times. 4 times 3 is 12, so we subtract 1, bring down the 2. 3 goes into 12 4 times, and 4 times 3 is 12, and that's 0, and then bring down the 3. 3 goes into 3 once. So that's just a quick review of long division, right? So that's just going to be something that you might have to do. All right, so this is not divisible by 2. Is it divisible by 3? 5 and then 6, 7, 8, 9. It is divisible by 3. So what's 441 divided by 3? 147. And then what is this divisible by? 7, 8, 9, 10, 11, 12. So that adds up to a number, so it is divisible by 3 again. And what does it end up being? So we get 49 is left. And then what do you notice about 49?
7.
It's definitely divisible by 7. It's actually 7 squared, right? So, okay. And then I'm left with a 1 here. So I divided everything out completely. So 2646 is equal to 2 times 3 times 3 times 3 times 7 times 7. That's it broken down in expanded form. This is expanded form, which means I'm not using any exponents to write it. But if I were to write it with exponents, what would it look like? 3 cubed, and then 7 squared. Okay, so let's write that here. 2 times 3, and then to the power of 3, and then 7 squared. So that's what would the prime factorization look like. Sound good? So our technique was we used repeated division to break it down. I spelled break wrong. Break it down to prime numbers. Okay. Now for number 2, we need to determine the greatest common factor of 126 and 144. Now here, we have to remember a few key words. So what does greatest mean? Biggest, largest, right? What does common mean? They have the same. And then what does factor mean? Something that multiplies, yeah, or yeah, we could also say goes into. So we're looking for the biggest number that is the same that goes into both of these numbers. Okay, so we have to find the biggest common factor that they have. So 126 and then 144. What we're going to do is we're going to find all the prime factors that are in common. Okay, so we're going to find the prime factors that are in common, and then we're going to multiply them together so that we can get our final answer. Okay, so what is a prime factor that goes into both of these? 2. All right, so what is 126 divided by 2? 63. What is 144 divided by 2? 72. Okay, now I need to look for another factor that they both have in common. Is it a 2? No. Could it be a 3? Yeah. Well, there's no 2 left, so it can't be a 6. Okay, so it could be a 3. Someone yelled out 9, and I'll show you why you're correct also. So here, if I take a 3 and I divide it here, but 9 isn't a prime number, right? That's something you have to remember, but it'll still work out. All right, so what's 63 divided by 3? 21. What's 72 divided by 3? 24. Okay, now, what's the next thing to do? We can divide both of them by 3 again. And what am I left with here? 7 and 8. Now, what do we notice about these two numbers? No more common factors. Okay, so what we do for greatest common factor is we take these numbers here and we multiply them together to get our final answer. So our GCF is 2 times 3 times 3, which in this case is 18. So we can just... No, these are not in common anymore. These numbers don't divide into both of these. We only want the numbers that they have in common. Okay? And the key word here is common. So try to remember that. All right, so GCF equals 2 times 3 squared, which is equal to 18. All right, so now we're going to look at the lowest common multiple. Lowest common multiple. I've got 3 numbers here. So I need to look, first let's look at what the definition of lowest common multiple is. What is multiple equivalent to? Multiply. So we're counting up by, if we were to count up by 28, 42, and 63, when would they get to the same number? That's what we're looking for. When would they get to the same number? That's what we're trying to figure out, okay? Now, it's these numbers are going to get big, and it's really tough to count up by, and you're going to get tired and run out of steam if you're counting up by, and who knows how long it's going to take. So I'm going to show you a method here that works really nicely, where we can take out all the common prime numbers, so we're not doubling up on anything, and find the lowest common multiple. So our setup is the same as what we did before. Okay, and we're going to do almost the same thing as before, but we are going to use more numbers this time. So let's, what goes into all of these? These are all multiples of 7, right? Yeah. Okay, so what is 28 divided by 7? 42 divided by 7. 63 divided by 7. All right, so now all three don't have something in common, but these two have something in common. What is that? All right, so now I didn't do anything to this 4, right? So I'm just going to write it down again. And then, excuse me, 6 divided by 3 is? And then 9 divided by 3 is? Okay. Now, these two no longer have anything in common, but these two do. What's in common here? 2. Okay, so now what do I end up with? 4 divided by 2 is 2. 2 divided by 2 is 1. And this nothing changed with that, right? Okay, now I could keep going, or I can realize, well, this is a prime number and this is a prime number, so I can just use those numbers here, right? So that's going to be a 1, that's a 3, nothing changed, and then take the 3 out, and then that's going to be a 1, and then those are all 1s, okay? So I take out all of the prime numbers that are possible. Now all these numbers here, I'm going to times them together. So my lowest common multiple is equal to 7 times 3 squared times 2 squared, right? So it's the 7 times 3 times 2 times 2 times 3. I just reorganize them so that they're together. So what does that actually equal to? So that's 252. So my lowest common multiple is equal to 2 squared times 3 squared times 7, which is 252. So that means if I were to count up by 28, and if I were to count up by 42, and if I were to count up by 63, they would all meet up at 252. Okay? And I don't have to count up by when I'm doing it this way. All right, and on the next page, there's a couple of questions that are word problems or situations that we have to look at. And we have to decide, are we figuring out lowest common multiple or greatest common factor? Well, the question says, what is the side length of the smallest square that could be tiled? Okay, so here, I need to make a square. Make a square. Okay, what is the side length of the smallest square that could be tiled with rectangles? So what can I use? Use rectangles. Okay, so I can only use rectangles in here. I don't know what size rectangles, but they all have to be the same. So I've got the rectangles. They have the measure of 8 by 36. And we have to figure out what size of square could be made. What is the smallest square that could be tiled with rectangles that measure 8 by 36? You can't cut any rectangles, so you need to make a square using rectangles. So you're going to be using a rectangle, which are two different they're different, they have different length and width, right? But you eventually have to make a square where the length and width are equal to each other. So you are going to be counting up by, count up by 8 and 36 to get to the same number. So what concept is that? That's lowest common multiple of 8 and 36. So real quick, what is that? So 8, 36. So what do they have in common? 2, 4, 18. They have a 2 in common. 2, 9. And then I keep going, right? So I don't want to double up if they share it. That's the idea of taking the common ones out. So 2, 1, and that's 9, which is 3 squared. Is it okay if I just shortcut it like that? Okay, so now my LCM is 2 cubed times 3 squared, which is 8 times 9, and it is 72. So 72 bananas? Inches? Inches? Just inches? Because what am I finding? I'm finding 72 inches here and 72 inches here. So that is the diagram. And then my little rectangles are 36 by 8. And so how many rectangles am I going to have along here? And how many rectangles am I going to have here? So how many rectangles are going to fill my square? Okay, good. Because 72 divided by 8 is 9. So you're going to have 9 up here, and you're going to have 9 down here. So you're going to have a total of 18 rectangles filling that. That's how many tiles you need. Okay, cool. Last one here. So this one says, what is the side length of the largest square that could be used? So you're going to use squares, could be used to tile a rectangle. So to make a rectangle that is 8 by 36. Well, see here, this one, you want to end up with a rectangle. You want to end up with an 8 by 36 rectangle. And you have to use squares to fill it up. So what size of square can you use where you won't have to cut anything? So this concept is, what size square will fit perfectly? So this is the greatest common factor. So what's the GCF of 8 and 36? So we have to look for all the factors that are in common, right? So I can, if I know that 4 goes into both, I can just divide 4 out right away. I'm left with a 2 here, and what's left here? 9. So now here there is nothing in common, so I stop. Okay, and 4 is my GCF. So what size, what does my tile look like? It is a 4 by 4 inch tile that is going to fill up this space, right? So how many of those little rectangles are going to fit in here? okay, because I have 36. Each of these, if each of these are 4, I go 36 divided by 4. And how many can I fit on this row? 9. And how many can I fit on this row? 9. Okay, so I can use 18 tiles to do that. So be careful. It sounds similar to the question above, but it's different. You have to kind of look at the situation. All right. All right. Perfect.